Hi. Thank you. Go ahead, Lowell.
This is Saul and Lowell with the demonstration of our final project for observational astronomy, Astro W3646.
For fall 2015. Hello, future users and Professor Shimonovich. Okay. As you can see here, we're on a Mac, clean desktop, have a file browser open, and we're going to go through the first and only steps, which we have put together here at the end in the appendix in case you don't want to read through the paper to get this thing to work. So first thing we're going to do is open up Terminal and clear, and we're going to create the git clone repository right on the top level directory. And this is going to take a minute.
Yeah, we've got about 400 megabytes of data from MDM that are included for tests, and they'll be downloaded from the Git repository.
It looks like it's going slow.
So what our program is going to do is it's going to keep track of the files in a directory, and what we'll do is we'll load them in over time, simulating them being taken in real time. That watch directory will then have functions run on it, and these functions are user-defined, extensible, and all the output will be cataloged by the program and checked for completion.
Yeah. So once this is done downloading, we'll get moving, but while we're waiting here, we'll see that we're going to bring this repository in, we're going to open up the file, we're going to initialize a directory, initialize another directory, we're going to open up our pretend data saving program, which is going to simulate the data that would be saved over an observing period, the course of a whole night, although in this demonstration we of course are going to do it very quickly with intervals set to 1 second, which is as quickly as we can, well, it's not as quickly as we can do it, but it's very quick. So we're going to blast through a whole night in about a couple minutes, and we'll cycle through a few different types of data showing that we'll move from different directories, different kinds of data, doesn't matter. And
then we'll run functions, which could really be anything. The main type of function is takes a file, writes a file. Can do whatever it wants in the middle, and this is in Python. Our program could act to read in any already written Python files as long as they obey our restrictions,
which are liberal and straightforward. So the two operations we will be running in this example will be a point source identifier, which is going to find our top 100 point sources in any picture, which is why we limited the images we're using to ones that have stars that are renderable as point sources. And a PNG generator, which is a fun little tool. All right, Lowell, we're done with that first step. So now we can check, do a little look here. We do have the ImagePop and the CD into ImagePop, and we're looking here. Everything looks good. That's nice, right? So now,
and this is the same contents that you can download from our Git repository using the link provided.
All right. Now, I don't know why we didn't do this for you, but who cares? We're going to make this test target directory, and what this is the directory which serves as the place that your images would be saved wherever you are saving them, whatever facility you're at. This is the place, the directory that you're saving data to while you're observing, right? So once again, you're observing all night, you're saving data. What this program is going to do is going to be alive in that directory, and it's going to be going to work on things that you know you're going to do to your pictures beforehand.
Yeah, so the target directory here is referenced in the documentation as a target directory. Wherever you are targeting with our program is the target directory. It's acting as the reservoir.
Right.
It'll have something filling it and probably something draining it. The something draining it is our ImagePop. The something filling it is our mock data sender.
Well, when we say draining it, we don't really remove the real file, but we drain a copy without actually draining it. Okay, so this is the next command. We're going to call this Python. We're going to call ImagePop, and we're going to throw it an init argument, which is going to initialize the ImagePop target directory which we just created. So I'm going to hit enter here. It's going to give us a double check, make sure that was the right one. We could enter a new path, but we're not going to. And it says it's good. Now, go ahead.
Now we are going to ls, and we should see that there's some new files.
Right, particularly
the README.
Yeah, no, not that one.
ImagePop README.
There it is.
So if we cat or look at ImagePop README.txt, this is generated by ImagePop in any calling directory. So it's not inside of the target. The target is for your input data. This is generated for the user wherever they're running. That way they can see the output and get some help if they aren't sure what's going on.
Right. Okay, so now we are initialized. Go ahead, Lowell.
Also inside of ImagePop target, if we want to ls that, the signature of having been initialized is ImagePop init.txt. This indicates that the directory is ready to have ImagePop commands on it and is a machine readable file.
And we do see the alpha, which is indicating the red. It did read the proper version, which doesn't really matter. Okay, so next thing we're going to do
Clear.
is clear. Good idea, Lowell. Let me do here. Okay, so now that we have initialized it, what we're going to do is we're going to run here, and that's going to give us a configuration file, even though we're not running with any arguments. We're just making a configuration file to set the time intervals to this for this demonstration because it's got to be fast.
So running in this way is not the normal way you'd run. Normally you'd be passing arguments after what we've just typed, and those arguments would correspond to the point source finding function or the PNG generation function. However, for us, just calling run on an initialized target directory will provide the user a config file to work with.
Which we can edit here.
And here is the config file. This is generated by ImagePopPy, and we need to change one of the values.
We don't want to wait 10 seconds because we want to get this demonstration over quick, and we will have a 10-minute thing here. That's good. Cool. Done with that. Okay, so now we're going to make our terminals and get everything ready here. What's up?
Yeah, while Saul's doing that, the config file is meant to be human-readable Python. Even someone without programming experience should be able to look at that config file and tell that there are values being assigned numbers or, things like that. There are some areas where strings are required, and for those, follow the instructions in the config file and in the other documentation to make sure that the strings you're supplying are properly formatted. If you modify a config file in some parent directory, anytime you run ImagePop for any number of children directory, the same config file will be sourced if it's possible.
Okay, cool. So let's run ImagePop here.
We just have to make sure that all these terminals are in ImagePop first.
This guy is not, but he is. I'll get him over here. Thank you, Lowell. Okay, cool. So this guy, drop this right here. So we're gonna call Python ImagePopPy run. This time we're gonna give it the target directory that we want to run it on, like last time, but we're gonna throw it the argument starfind. And what that's gonna do is start up starfind. There are no files to be found there. Ideally, this is how you would use this program before you've ever captured a picture earlier in the day from home before you leave. It doesn't matter. You set this up, and ImagePop's just going to be waiting for you to take pictures.
And before we start, we're going to have a second terminal on the right using the output directory made by SF, and we're going to make PNGs of the output of that function. So we're going to do a two-stage demonstration, the first being the SF, and on the output of SF, we're going to run PNG. So we're going to have the middle terminal for things happening to the ImagePop target. We're going to have the right terminal for things happening to ImagePop target /SF, which was the directory generated, that will be generated, by calling the command that Saul has. And then we'll start filling in data.
Right. Okay, I'm going to go ahead and run this, yes? All right. It's going to ask us again to make sure we did everything right. We did. It locked in, and this is an idle. It's waiting for files to be saved or written to the drive. Now, what we can do over here now is we can, what we want to do is go into, well, if we look here, we'll see Starfind, I think. Or no, we need to go into the target, sorry. CD into ImagePop target. Huh. No.
We need to stay in the ImagePop directory,
Correct.
but run things relative to ImagePop target.
Well, I wanted to show that it was there.
You can ls.
Actually, we can look at it right here.
It's fine. You can ls ImagePop target.
Oh yeah, I can. Well, there's Starfind.
Here's
it
Starfind.
exists.
So the file has been generated by the idle process in the middle terminal.
It's output file.
In our right terminal, we can now call a similar line, but
We're
first
gonna initialize it.
Yeah.
We always initialize a directory. So now we'll initialize that newly created output directory. Booyah! It dropped the. You see the file get dropped here, and these guys also get written here, which is indicating another initialized directory. Very similar. We're going to run this command here, which is going to kick up the PNG function, which should be waiting for the output of the Starfind function, and make some nice PNGs for us to look at.
Now, both of these idling terminals have a time limit. We have that set in the config file, and the user is free to modify it. But right now, we have a 10-minute time limit on both.
Okay.
Since the middle terminal has been idling longer, we're going to get going right away with our mock data.
Yes.
And what we should see is the mock data sender being executed in the left terminal, which will begin writing files to the middle directory, ImagePop target. As ImagePop target fills, every second it checks for what new files have been added, attempts to run SF on them, and attempts to generate output inside of ImagePop target/SF. That output being generated from the middle terminal will be interpreted as input by the right terminal. And every time a new output file appears, the right terminal will begin interpreting it and generating PNGs of those files.
Correct. We can see now Starfind has sniffed its first prey.
So the left terminal has copy operations. That is on its 5th or 6th operation now.
Mm-hmm.
The middle terminal has completed 3, and the right 4 or 5. Right terminal has completed 2.
And on the very right, we're watching the file system build with all the output.
This is how the program will save you time and frustration.
And of course, this can be elaborated, to your imagination's limit.
Yeah, and for now, what the program is, what the functions are doing doesn't really matter. What we've established is a workflow. You've got your existing data production methods dumping into just a file. As long as you can copy it into a file, this will work.
Yeah, this will work.
The middle terminal is handling the input, looking for new files, and updating its output as it can.
Running Python functions that can be easily fitted to run in this method, which is nice.
So just to talk about what SF is doing a little bit, simply it looks for point sources that are well above the average value of a 2D average of a 2D data array, and tries to isolate them from any other point source within a radius defined by the function. I think it's 4 pixels. Essentially, you're going to keep the coordinates of the center pixel of a bright point source and zero out the data around it within 4 pixels.
Yeah.
What PNG is doing is using Python's matplotlib library to take in a FITS file, which is assumed to have a 2-dimensional image in its 0th HDU, and it's going to generate a plot of that image and then output it as a PNG file. In both instances of ImagePop, the messages that you can see in the beginning of the terminal are being routed to a log file. That log file can be specified by the user and will be appended to during each run of ImagePop. Most messages are benign or recoverable. The program would fail upon fatal errors. If an individual function throws a fatal error or any type of error, it will be caught by ImagePop, and it will be recorded as a message in the log file, which we have as imagepoplog.txt. So the user can still recover error messages from the output of the functions without having it interfere with their data.
Right. An ImagePop run a second time if you fix whatever the error was. We'll know not to do anything with the files it already operated on. It'll find the ones it hasn't operated on. It'll do the operation if it can, if you can fix that problem. And
yeah, the best thing about ImagePop, the meat, is that it's writing a text file containing all the names of the files it tried to work on. It's keeping a text file of all the operations it's ever been tasked with doing in a directory. And it's keeping a CSV file, a table, which is keeping track of the timestamps that it thinks a file should have been last updated. For instance, if the input was updated later than the output, it'll know that you've changed a file in your input directory, and it will know to rewrite the output file given your new updated input. If a new file is found, it'll append a whole row to this table, and it'll zero out any of the outputs, telling the program that no outputs have yet been generated from that input.
okay, so we just finished the simulated data dump. So we just blasted through a whole night of observing. And ImagePop is wrapping up here with the last little bits, it looks like, or it might be idling.
So even if both programs are idling, they will cut out at their 10-minute mark.
Right, which we defined.
Right. Looks like the PNGs are still maybe just to the last one.
It's the last one, so we're good.
Yeah. So at this point, the user could always Control-C out of their terminal shell, but we are going to let these go.
Yeah, so I'm going to show you what happens. Wish we could probably look maybe at the output. I don't really know. I didn't think about it.
Sure. So let's show them a FITS file from the input, a FITS file in the SF, and then a FITS file in the.
Sure. Okay, so the ImagePop target directory is going to have inside of it
The originals.
the originals, which are here.
Yes, the originals.
So we can look at something like 63B fits.
Great.
Bring him up.
And let's
Here's our
also
guy.
open the SF version of 63B.
Yes. Now if we go into SF, which is this output directory was written here, we will slide down, we'll close PNG, and we'll go to 63,
63.
maybe a little.
Great. And then, last but not least, will be a PNG.
Which 63 is probably right here. 63
Yes.
PNG.
The naming convention you see in the PNG function is indicative of the fact that all these functions may be required to read one file and write one file, but they are allowed to, of course, write more than one file.
Oh.
So this PNG function writes a file with the name of its input that contains only the name of its actual output, and the actual output will be named properly as a PNG file. So what we're seeing in the difference between the two FITS images is very, very small. Only small Gaussian changes have been applied to the image and filtering. The PNG generated looks very similar to the SIO image output. As you can see, this is definitely the same object that's only been same file that's been acted upon in simple ways to demonstrate operability.
Yeah, we should have done contours. Okay.
So now, actually, if we close out of the PNG, we can do another demonstration.
So it's on the same files.
On the same files. So if we first
Maybe here.
kill our PNG program,
Sure.
you see that even though we killed it, it unlocked the directory properly and properly finished. The keyboard interrupt error message remains, but no big deal. That's fine. We can run almost the same command again, except with the argument PNG_contour.
Underscore Nope. T. You are.
Nope.
No. Sorry. No. Oh, look, she just
Yeah,
finished.
as you can see, the middle terminal finished nicely, neatly. TOUR. That's all.
Sorry. Where are we?
Back, TOUR.
I'm sorry. I'm not paying. I don't know where we are.
TOUR.
CONTOUR. Thank you.
Enter.
Sorry. Okay. Well.
Do it.
Oh, sorry. Yes,
Enter.
it's gonna ask us. Yes, we know what we're doing. Okay, cool. Let me drop this back down real quick so we can just see that she should have
So we've now made another
contour.
output directory using
Which-
the SF as input.
Right, and it's gonna fill up right now. Very nice. Which one did we look at? 63?
63B.
Whenever that comes up.
PNG contour is a bonus included. It's just another plot function very similar to the imshow in Matplotlib, except this will make a contour map of the 2D fits HTU image. As soon as 63B is generated, we can pop it open, but
In the meantime, whoops. Oh, so maybe we should talk about the dummy files.
already did.
Already did. Excuse me. So I'm not paying attention. That's not 63, but it is a thing.
So our point sources are kind of indicated with this lily pad design, and that's just there to indicate that it's a point source. Nothing really super fancy about it, but it did find point source at those locations. But as soon as 63B generates, we'll be basically done.
Where is it? What's going on? We're in 120, 420.
Top.
Oh,
Oh,
excuse
it's
me.
almost there. No, it's not. It's not made yet. Oh, it'll get there.
That's interesting. Here we are.
Those are pretty. This is what, Orion?
Yeah, that's Orion.
Yeah, these are the coolest looking ones. So the center 4 point sources identified are inside of the nebula.
And we should be.
And there's 63B. .png.
Got it.
Dot.
Did I get it right?
Yeah.
I got it right. There we go.
Oh, wow.
Right. So
If we
bring this
compare
down.
that with the data, as you can see, we pulled out all the images.
Yeah, look at that.
Vignetting is not handled by our functions, but a user more accustomed to their own data sets could definitely handle that. It's nice.
Yeah, they're very nice. Well done, though.
So I think we're about ready to close out of SAO and the image preview.
She's done.
And since the program is idling, we can kill it without fear.
And this is how it closes by itself.
Yeah.
Okay. So, obviously, we're good.
Yeah, so this has been demonstration of ImagePop. Check us out on GitHub.